Okay.
Okay, so we are doing problem 18 from section 13.1 right now. And the problem says, if two sides of a triangle have lengths 31 centimeters and 85 centimeters, and the measure of the third side must be a whole number of centimeters, what is the longest the third side can be, and what is the shortest that the third side can be?
Can you hear me okay?
I just was able to hear you. Were you saying something else?
No, I just keep getting these messages that my microphone and
Yeah.
speaker are not working. So
Okay, so we'll label this one as 31 and this one as 85. And keep in mind, if you flattened out those two sides to a straight angle and made it completely flat, then you would have just 85 plus 31. So you'd have, what is that, 116?
One six, yeah.
If you flatten it out, but then you don't have a triangle anymore. So what's the maximum that that third side on the other side could be? What's the longest the third side can be if you have to have a whole number of centimeters?
would it be 115?
It would be 115 because it would have to be one less than 116. Okay, now the other question is then what if you had that side with the 31? What if you swung it the other direction? What if you went like this with it? What's the minimum that that third side could be? So we still have 31 here. We've got to figure out what's the lowest it can be. So that in any two consecutive sides, if you add up those sides, the opposite side is less than that sum. So 85, we can call this x. 85 plus x would have to be greater than 31. And 31 plus x would have to be greater than 85. And 85 plus 31 would have to be bigger than x. So given all of that information, how can we find the minimum?
I don't know.
Wait, so the longest it can be is 115 because it's 16.
Yeah, 85 plus 31 is 116. And that would be if you just squished down this vertex C, if you squished it down so the triangle were flat, that would give you 116, but that sum, the sum of any two sides has to be greater than the third side. So the third side here couldn't be more than 115. That's the longest it could be.
So would it be 85, 30 minus 31?
Oh, it has to be 54, 50, 55.
Okay, let's try that. So if we take
So you
85
take-
minus 31,
X has to be greater than 54.
85 minus 31 is 54. So now if we flattened out the 54 and the 31, if we took this vertex B and just squished it this direction, 54 plus 31
It's 85. 85.
would be 85. So that would make the sum of those two sides equal to the third, but that's not good enough because that just flattens it. You need those two sides to be greater than the third side. So 54 is a little bit short.
Okay, well, what if you made it 55?
Yeah, if you made
55.
it 55, then 55 plus 31 would be 86, and your sum would be greater than that third side, so you'd be good. So 55 would be your shortest, and 115 would be your longest. Okay, and does anybody know the name of that theorem that we were using just
Oh,
now?
you told us the other night.
Called the triangle inequality, that says the sum of the lengths of any two sides of a triangle is greater than the length of the third side.
You said triangle inequality. Sorry, my guinea pig is having, hold on, excuse me. Hey, hey. Hey, Phoebe.
Okay, so that says that the sum of any two sides in a triangle has to be greater than the third side. And that has to hold no matter which two sides you're starting with.
So that helps us answer number 17 then.
In 13:1,
Yes.
Right.
Yes, ma'am.
17 says, can the following be the lengths of the sides of a triangle? So you just have to check the pairs. So on 17A, you've got 20 plus 40 has to be greater than 50, so that works. 60 is greater than 50. Is 40 plus 50 greater than 20? Yes. 90 is greater than 20. And is 50 plus 20 greater than 40? Yes, 70 would be greater than 40. So 17A would be a yes. And this is in 13:1.
Wait, mine says 23, 50, and 60.
Yeah.
Mine said 20, 40, and 50.
Yeah, I've got 20,
I
yeah.
have a B is 10, 40, and 50, but
Oh,
A
I'm
is
sorry,
23.
I'm in 13:1B instead of 13:1A.
Oh,
Okay.
yeah, that's what I've got.
Okay, let's go back. 23, 50, and 60, is that what you have?
Yes.
23, 50, and 60, yes.
Okay, so is 23 plus 50 greater than 60?
Yes.
Yes.
Okay, is 50 plus 60 greater than 23?
Yeah.
Yes. And is 60 plus 23 greater than 50?
Yes.
Yes, so A is a yes. Now let's check B. Is 10 plus 40 greater than 50?
No.
No, it's equal to 50. So that would be a flattened out line or segment, not a triangle. Now, when you're doing this with students, a fun way to do this is with spaghetti noodles and have them measure out the 10 centimeters, the 40 centimeters, and 50 centimeters and try to make it. trying to make that triangle.
Oh,
And if you've got, if you've got pieces of spaghetti that are like this, they don't meet. There's no way they can meet. Because these two sides are too short. So it's a fun discovery activity, really. The 17B and 13.1 would be no.